exponent here by a quarter using our laws of indices. So a quarter times 20 is 5, a quarter times minus 8k is minus 2k, so this is e to the 5 minus 2k. And we still haven't used the fact that the series is convergent, right? What this means is that, like we said, the absolute value of r is less than 1. But when you have an exponential, right, or any number raised to some power, and you're saying that this number is less than 1, what that means is that the power, right, the exponent, has to be, a negative power, right, less than 0, because the only way you can take some number and raise it to some power and get a number smaller than 1 is if you have a negative power, right? So what that means is, all right, is that the exponent here, okay, actually needs to be less than 1, right? So what that means is, less than 0. So 5 minus 2k needs to be less than 0, right? Because it's the only way that the absolute value of r is going to be less than 1. And then we just, solve this inequality, and we see that gives us that k is greater than 5 over 2. Okay, so first part done, it's not actually that bad, but then we have to, use the fact that the sum to infinity is greater than 10 to find the possible range of values for k. Okay, so we know it has to be greater than 5 over 2, but clearly this is going to lead to some sort of bound from above, which stops it being bigger than a certain value. So we know that the sum to infinity formula involves knowing the first term, so we need to work out what a is, but that's pretty straightforward. Once we know r, we can just use this relationship here. So we know that u2 is e to the 15 minus 6k, and we know that this has to be equal to a times the common ratio. Well, the common ratio we found it is 5 to the e to the 5 minus 2k. We can just divide both sides by this. Again, same sort of logic. Right, we're going to have a 15 minus a 5 here, so e to the 10, and then a minus 6 minus minus 2, so minus 4k is equal to a. So then we can go ahead and, form an inequality using the fact that we know that the sum to infinity is greater than 10. So we know that the sum to infinity is equal to, so a we just worked out is e to the 10 minus 4k over 1 minus r, so 1 minus e to the 5 minus 2k is greater than 10. So we can multiply across by this denominator here because, we're going to try and find something to do with k, right? Some sort of, inequality relating to k. And, we don't want to be working with this fraction, so we can sort of move things around, etc. So doing this, what do we have? We have e to the 10 minus 4k, and then we have is greater than 10 minus 10e to the 5 minus 2k. Now, whenever you're dealing with equations or inequalities that involve exponentials, you always need to be on the lookout for the following thing, and that's if you can spot that one of these exponentials is just the other exponential squared, right? So what I mean by this is if you look here, we have, e to the 10 minus 4k, right? This is just equal to e to the 5 minus 2k all squared, right? Because when I use my laws of indices, right, I can just multiply this power of 2 in. And what that means is that we're dealing with one of these hidden quadratics where we can sort of make that substitution, say y is equal to e to the 5 minus 2k, and then this is actually going to become a